momentum. Torque we have studied, no? Now we are studying angular momentum. So torque is an axial vector, theta is an axial vector, omega is an axial vector, L is also an axial vector. Angular momentum, it is represented by L. L is also an axial vector. It means what will be its direction? It will be in the direction of axis of rotation, either in upwards direction or downwards direction. Clear? Now see. So what is meant by linear momentum? For example, this is a body of mass m moving with a velocity of v. Then its linear momentum is mass of the body multiplied its velocity. Mass into velocity is called linear momentum. Clear? But we are studying angular momentum. Angular momentum means what? Momentum in the case of rotational motion. Okay, now see. So this is the axis of rotation. Around this axis, this is a body of mass m moving with a velocity of v. Okay, this velocity is inside the board. It is not in the plane of the board. This velocity ఎలా ఉంది? బోర్డు లోపలికి ఉందనుకోండి. ఇంకా దాన్ని బొక్కబెట్టి డ్రా చేయలేం కదా, అందుకని ఇట్లా డ్రా చేస్తున్నాను, కన్ఫ్యూజ్ అవ్వద్దండి. So this velocity is present inside the board. Are you able to understand? Therefore, what will be its angular momentum? So angular momentum can be written as, I can write R into P. I can write like this, where P is called as linear momentum. Okay. So it means linear momentum multiplied by perpendicular distance from the axis of rotation. That relation we call it as angular momentum. P is called what? Linear momentum. This body has some momentum, no? It has some mass, it has some tangential speed. Okay, V means with speed, tangential speed. So mass multiplied by tangential speed is called momentum. And its perpendicular distance from the axis of rotation, that is R. So moment means what? The product of radius and linear momentum of the body is called as angular momentum. Or you can call it as moment of momentum also. Another name for angular momentum is moment of momentum also, you can call it as. Okay, moment of momentum means what? Momentum multiplied by perpendicular distance. Okay. Torque also we call it as momentum, moment of force. Torque ki inko muddu peremi, it is also called as moment of force. Why we call it as like that? Because force is multiplied by perpendicular distance, no? So wherever you multiply by distance, that is called as moment. Are you able to understand? So angular momentum is also called moment of momentum. Okay, ma? So therefore I can write, what is R here? R is perpendicular distance from axis to linear momentum. Linear momentum, or you can call or velocity of particle. Velocity of particle. So R ante ఏ distance తీసుకోవాలి మీరు? Velocity కి perpendicular direction. In torque also we have done the same thing, no ma? We have taken perpendicular distance to force. Then we have multiplied radius vector and force, we got torque. Here also same concept. You take which distance? You take that distance which is perpendicular to velocity. And that is R, no? So R into P is called as angular momentum. Clear, no? P can be written as M into V also, no? So I can write R into MV also. This is another form. Are you able to understand? So this is called as angular momentum. So in vector form, how can I write? In vector form, same angular momentum can be written as L dash is equals to R dash cross P dash. I can write like this also. Angular momentum we studied, it is a vector quantity, no ma? So how to give its direction? This is the method in which you can find out the direction of angular momentum. R dash cross P dash. Are you able to understand? Or also you can write M, if you take common, R dash cross V dash also you can write. Because M is a scalar quantity, no? Mass is a scalar quantity. You can take it outside. So just you can take the product of R dash cross V dash, cross product. Okay. Now see ma, for example, this is the radius vector and velocity is inside the board. Now can you say what is the direction of angular momentum in this condition? Angular momentum ఏ డైరెక్షన్ ఉందో చెప్పండి. Already we studied angular momentum is a axial vector, no? So either it should be in upward direction or either it should be in downward direction. Which direction is correct? Upward direction. How can you say? So place your right hand on r dash. This is the first vector, no? Place your right hand on r dash. Velocity is in which direction? Inside the board. So rotate your fingers inside the board. What is the direction of thumb? Thumb is in the direction of axis, no? Are you able to understand, no? So therefore I can say this will be the direction of angular momentum. Okay? So when velocity is inside the board, angular momentum is on the axis towards upwards direction. Are you able to understand, no? Angular momentum can be in this direction also, downwards also. Downwards in which condition? When particle is coming out of the board. When velocity is out of the board, then you have to do r dash cross b dash, no? Particle బయటకు వస్తుంది అనుకోండి, r dash cross b dash. Then thumb is towards the downwards of this axis. Now it is present on the upside of this axis. That's it. That is how you can find out angular momentum. Understood, Nama? Similarly, for example, if I take one body, let us take one case. Clear, no? For example, this is a body of mass m at a distance of r, and consider velocity vector is in this direction. Okay? Velocity vector is in this direction. Then how can you calculate its angular momentum? So this is radius vector, no? So you can extend this radius vector here also, no? You can displace radius vector, no? Displacement of vectors we have studied, no? Vector can be displaced anywhere. Just its direction and magnitude should not change. Okay? So therefore what is this angle? This is the angle theta between radius vector and velocity. So therefore what you can do, split this velocity vector into two components. Split velocity vector into two components. Clear, no? Then this is velocity, no? Which is the opposite side? V sin theta is the opposite side. And which is the adjacent side? V cos theta is the adjacent side. Now out of V cos theta and V sin theta, which vector we have to take? V sin theta. Why we have to take V sin theta? Because that is the velocity vector which is perpendicular to radius vector. Radius ki perpendicular ga unna vector ade kada V sin theta. Okay. Namaskaram. Absent aithe atte untadi. So therefore, how can I calculate angular momentum? R into mv sin theta. Are you able to understand? So directly I can write r into p. In which condition? R into p I can write when radius and momentum when they are perpendicular. But when radius and momentum when they are at an angle of theta, you can use this relation. L is equals to r into mv sin theta, or just you can write mvr sin theta also you can write. But to find out direction, always you have to use this relation. R dash cross p dash. You should not use p dash cross r dash. P dash cross r dash use చేసినానంటే డైరెక్షన్ తారుమారు అయిపోతుంది. క్లియర్ మా? R dash cross p dash. Okay, this is the equation. So finally what we understand, we have to take those two vectors which are only perpendicular to each other. Radius and velocity vector, they must be perpendicular. Take only those components. Understood, no? That's it. So we are writing another equation for angular momentum. One equation already we have studied, no? One equation is R into P, or you can write MVR. Okay, ma? Now see here, this is a point mass moving with a tangential speed of V, and velocity is inside the board. And what is the perpendicular distance? Perpendicular distance is R. Then these are the equations of angular momentum. And this is a point mass, no? For point mass, what is the moment of inertia? mr square. Okay. But here in this equation, I have only m into r only. But I require r square, no? So I multiply and divide by r. So will anything happen, ma? If I multiply and divide by r, nothing will happen, no? But here, m, r and r, it will convert into mr square. And additionally, what I have v divided by r. And tangential speed, we know it is omega into r, no? So therefore, omega is equals to v by r. So therefore, instead of v by r, I can substitute omega. Instead of mr square, I can write moment of inertia I. So therefore, L is equals to I into omega. This is another equation for angular momentum. Understood, Nama? One equation for angular momentum is MVR or MVR sin theta. And another equation is I into omega. So these are the two equations of angular momentum. For torque also, we have written two equations, Nama. Torque can be written as R into F also, I into alpha also. This I into alpha is in terms of moment of inertia. Similarly, angular momentum also I can write in terms of moment of inertia, I into omega. Are you able to understand? So these two equations you should remember. Fine? Okay. Make a note. Okay, Seema. So next concept which we are studying is law of conservation of angular momentum. Okay. So before studying law of conservation of angular momentum, first of all let us revise law of conservation of linear momentum. Okay. What is law of conservation of linear momentum? Seema, on a body, if external forces acting are zero, okay, then according to Newton's second law, we have F net is equals to dp by dt. No? Rate of change of momentum of a body is directly proportional to net force acting on a body. Clear, Nama? If net force is zero, dp by dt is also zero. dp by dt can become zero only when momentum is a constant. Already we studied this one, no? Gurtunda? Okay, ma? If external force acting is zero, then momentum of the body will never change. It always remains a constant. That is called as law of conservation of linear momentum. Are you able to understand, ma? So, same concept if I apply in rotational motion, let us see how we can apply. See, ma. So, consider this is a disc. Are you able to understand, ma? Consider this is a disc rotating about this axis. So, it is rotating with a constant angular velocity of omega. It is rotating with a constant angular velocity of omega. Are you able to understand? If it is rotating with a constant angular velocity of omega, then it means what is the alpha value? Angular acceleration is how much? Zero. There is no acceleration. Angular acceleration is not there. Okay, ma? So you can write alpha is equals to d omega by dt. It is zero. It means omega is a constant. Are you able to understand? If alpha is zero, can I say net torque acting on the system is also zero, Nama? Clear, no? What is the formula of net torque? I into alpha, or you can say R into F. Okay? If alpha is zero, then net torque acting on the system is also zero. Are you able to understand, ma? Okay. So if a net torque acting on the system is zero, then angular momentum of the system is a constant. Are you able to understand? Same concept we are writing here. Force, net force is zero, momentum is a constant. Compare chestu chudandi. Net force is zero, what is constant? Momentum is a constant. Net torque is zero, angular momentum should be constant. Are you able to understand, ma? So therefore what I write, if net torque acting on the system is zero, then angular momentum should be constant. Okay. How to prove this one? I want to prove also. Okay, so let us see ma, same equation, how can you write in rotational motion? By using analogy. Instead of force I can write a torque, no? Instead of force I can write torque. Force and torque, they are analogous, no? Force produces linear acceleration, torque produces angular acceleration. So dP divided by dt, can I write dl divided by dt? That's all, no? P is linear momentum, L is angular momentum. So net torque is equals to dl divided by dt. This is the equation according to Newton's second law in rotational motion. Understood now? Now write the equation. So if net torque is 0, then dl by dt also will be 0. If dl by dt is 0, it is possible only when L is a constant. This is the proof of this. So system paina torque emi ledanukondi, angular momentum lo marpu emi undadu. There will be no change in angular momentum. Understood nama? Okay. So from this same equation I can write, okay, first of all let us write the statement of this one. So what is the statement of law of conservation of angular momentum? If net torque acting on the system, is 0, then angular momentum remains what? Angular momentum remains constant. Are you able to understand? No? So just like linear motion lo చదివాం కదా మనము, అదే కాన్సెప్ట్ మళ్ళీ rotational motion లో కూడా రాస్తా ఉన్నాం అంతే, పెద్దగా మార్పు ఏమీ లేదు. If net torque acting on the system is 0, then angular momentum remains constant. It means initial angular momentum and final angular momentum, they are same. Okay. क्या जी सुब्बाराव का चुप बैठे कब लिखती नोट्स हो या तो कहीं क्या నోట్స్ చెప్పేటప్పుడే రాసుకోండి, మా తర్వాత ఈ రాయాలంటే టైం వేస్ట్ అంతా. కూర్చొని హరికథ వినడం కాదు, నోట్స్ నీట్గా రాసుకోండి. ఓకే, అండర్స్టూడ్ నామా వాట్ ఈస్ హ్యాపెనింగ్ హియర్? నౌ సీ. So therefore now let us take this equation once again. So net torque is equals to, or we will do one thing, ma. So angular momentum is a constant, no? So therefore I have written L is a constant. Okay, L is a constant means what is the equation of L? mvr is one formula, I into omega is also one formula, no? So therefore if net torque acting is 0, then I can write m1 v1 r1 is equals to m2 v2 r2. Can I write like this? Can I write like this? If on a system, if torque is not acting, initial angular momentum, final angular momentum, they must be equal. Okay, how to apply this one in problems we will see afterwards. Definitely I can write like this, no? m1 v1 r1 initial angular momentum, m2 v2 r2 final angular momentum, they must be equal. Similarly also I can write I1 omega 1 is equals to I2 omega 2 also. Like this also I can write. This is another equation of angular momentum, I into omega. So I1 omega 1 must be equal to I2 omega 2. Like this also I can write. Are you able to understand? Okay. Now let us write one more equation for torque. Okay, ma? So already we have written, let us prove that one. See, ma, torque is equals to dl divided by dt. So d by dt of L can be written as I into omega. I is a constant, so take it out of integration. What is d omega by dt? Change in angular velocity by time is what? Alpha. So I into alpha. So this was the same equation we have been using, no? Torque is equal to I into alpha. This is the proof of this. How we got torque is equal to I into alpha. Are you able to understand, ma? So we know this relation. Net torque acting on a system is equals to dl by dt. L is I into omega. I is a constant. d omega d by dt is alpha. Clear now? That's it. Now based on this, we can frame many beautiful questions. So whenever you see the question, you have to identify this question is based on which concept. క్వశ్చన్ అసలు దేనిపైన ఫ్రేమ్ చేసినోడు అది ఆలోచించాలి, అప్పుడు మీరు ప్రాబ్లమ్ని చేస్తారు. అర్థమవుతుంది కదా? క్వశ్చన్ ఏ చాప్టర్కి సంబంధించిందో ఐడియా రావడం లేదు, ఇంకేం చేస్తారు మీరు? ఓకే.